This conference will now be recorded.
Hello. Hello. Is it audible?
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
Yeah, yeah. So I told you about k nearest neighbor.
Sir, why it is called lazy, sir?
It's called lazy algorithm because basically it's actually the accuracy, as you can see, means it is actually changing its means what to say. Its classes na on the basis of the value of k, on the value of k. It is actually changing its classes now on the value of k. Suppose if the value of k is 6, okay, and if it belongs to class A, we don't know when the value of k is going to be 7, it belongs to class B. Or say 8, it belongs to class B because the frequency, it matches the frequency na. On the basis of the frequency, it is actually giving the class prediction, right? Getting the point? Is it clear right now? Any doubt?
Yes, sir.
Okay, yeah, that's fine. Now, the next one. I'll tell you a few things. I'll tell you a few things. I'll go to Python 3. I'll create a new file. Okay, Python 3. And here I will go for, wait, GI class 4. JS class 4. Okay, so today we are going to go for class 4 or class 4. Let's move ahead. Now I will tell you something about linear regression, simple linear regression. Okay, simple linear regression. Now, what is actually linear regression basically? Okay, what is actually linear regression? So from the beginning, can you see the PPT? Is it visible?
Yes, sir.
Just have a look. Now here we have housing prices, Portland. Now these are actually some x-axis represent the size in feet, and y-axis is actually representing what? Y-axis is representing the price in dollars. It's representing the price in $1,000 or thousands of dollars. Okay, thousands of dollars. Supervised learning. This is also a part of supervised learning, regression. So we are going to do simple linear regression with one variable. Simple linear regression with one variable. Okay, simple linear regression with one variable. Okay, now regression problem means we are going to actually predict the real valued output. Real valued output. Real valued output. Getting the point? Real valued output means continuous output we are going to predict. Continuous output we are going to predict. Now, suppose this is actually our training set, which has got two columns. The first column is actually size in feet, and the next column is actually price in dollars. Oh, extremely sorry. Size in feet and price in dollar. Size in feet and price in dollar. So training set of housing prices, this is basically the size in feet and price in dollar. So size in feet is basically 2,000, 1,000, something like that. Price in dollar, this is basically, it is represented by Y. So suppose if the value is or square, size in feet square is 2104, it's actually 460. It's 1146 is 232. It's 1534, then it's 350, something like that, and it's go on. Okay, so can we say that size in feet column is basically our feature column, and the price in dollars is actually our target column? Can we say that?
Yes, sir.
Can we say that? Yeah. So here M represents the number of training example, X in actually the input variables and features, and Y's are actually the output variables and target variables. Or Y is represented as an output or target, as I said, or label you can say. Right? Now, just have a look. So here H theta X, H of theta X equal to theta 0 plus theta 1X. Theta 0 plus theta 1X. Now compare this example or compare this hypothesis. Compare this hypothesis with y equal to mx plus c. Remember y equal to mx plus c. Remember y equal to mx plus c. It was equation of a straight line.
Yes, sir.
Yeah. So basically
Yes.
here this black line, this black straight line is actually what? It is actually the prediction line. Okay, actually the prediction line. And in the equation y equal to mx plus c. In the equation y equal to mx plus c, I will just open the notepad once again. Okay, I will just y equal to mx plus c. Y equal to mx plus c. Here y is actually the independent variable. Independent variable. Okay, x is sorry, y is actually the dependent variable. Dependent. Okay, it's actually the dependent variable, and x is actually the independent variable, and m is actually the coefficient, and c is actually y-intercept. Okay, y-intercept. It's y-intercept. Getting the point? It's y-intercept. So this is basically the concept. This is basically the concept. Okay, so now compare this equation with this one. Okay, now compare this equation with this one. H of x theta x. Yeah, coefficient or slope. Yes, basically the same thing. You can say the coefficient or slope gradient, right? Coefficient of x. Got it? Getting the point? Yeah. Okay, so here I will just go for the current slide, and here as you see h theta x equal to theta 0 plus theta 1x. So y equal to mx plus c, y equal to mx plus c, mx plus c. So what is actually m? What is m? M is actually the, what is actually m?
The theta 1.
Yeah, theta 1. And what is theta 0? Theta 0 is basically what? It is c.
Okay.
C. Yeah. Here x, hypothesis, estimated value of y. So h maps forms x and y. So h theta equal to theta 0 plus theta 1 x. Shorthand, x represents what? X represents the independent variable or independent value, because the value of y is totally dependent upon x. So can we say that y is actually the predictor or the predicted value? It's the predicted value. Y is the predicted value, and x is basically the feature, right? Now, training set, learning algorithm, and the output. Okay, so this is basically what? Training set, learning algorithm, and we get a model. We get a model on which we are going to fit the input. The input is actually the size of the house, and we are going to get the estimated price, right? This is actually the theory of machine learning, isn't it? This is actually the theory of machine learning, right? Okay, so next, how do we represent h? How do we represent h? See, linear regression with one variable, or we can also say it's a univariate linear regression. Univariate linear regression. Why? It's a linear regression of one variable. Univariate. So linear regression with one variable and cost function, basically. See, they are telling what? I'm telling you what is actually the cost function. So if this is the training set which has got one column, that is the size and fit, this is actually the feature, and this is actually the target, the price in $100. This is actually the target. Okay, target. So hypothesis h theta of x equal to theta 0 plus theta 1x. Theta 0 plus theta 1x. Theta 0 plus theta 1x, right? So this formula is well known to us. Now, just have a look. Here theta i's is actually the parameters. Thetas are actually the parameters. And how do we choose thetas? Means how we choose m and c, means how we choose the slope and how we choose the intercept, y-intercept. See, theta 0 x equal to theta of x, h theta x is something like theta 0 plus theta 1x. This is the formula we know well. Now, if we consider the value of theta 0 as 1.5 and the value of theta 1 is 0, it would be something like this. The value of x is totally 0. The value of x is totally 0. So all the time the hypothesis will continue the same value, that is 1.5, and we are going to get some straight line, something like this. Okay. Now, if we consider the value of theta 0 as 0 and theta 1 as 0.5, we are going to get a line something like this. 0.5x. Okay. Right? And now if we consider the value of theta 0 as 1 and theta 1 as 0.5, this is the actual hx, or means h theta x. This is the actual value. This is the actual one. So we are going to strive for the third one. Okay, the first one we should not assume any values like the first one, neither the second one, otherwise it is actually making a total value 0. Getting the point? And this is how the third one is actually representing our model. Got it? Very simple equation of a straight line.
Basically, h theta x is y.
Yes, it is the hypothesis. Means actually we need to find out this. Yeah. We need to find out. Means the h theta x, this is actually the predicted value. This will be, means this we need to find out. This we need to predict. Getting the point? Anyway, any problem?
No, sir.
Now, so let's move ahead. So see, now one more question arises, that if if here, just have a look. If this is actually the prediction line, if this is actually the prediction line, and we definitely have some value of theta 0 and we have some value of theta 1, we have some value of theta 0 and we have some value of theta 1. Okay, the value of theta 0 and value of theta 1. So we need to minimize the value of theta 0 and theta 1. Okay, why? So that we get the least error. We get the least error. We get the less error basically. So suppose h theta x is basically x of I, h theta x of I. If this is the actual value minus yi, this is the predicted value, right? Getting the point? This is actually the predicted value. Okay, so if we subtract this two, we are going to get the error. Yes or no? 10 रुपया किसी चीज का दाम है और आप प्रेडिक्ट करते हो 8 रुपया, तो एरर कितना हुआ? 2 रुपया। 2 रुपया हुआ? हेलो?
यस सर।
यस हो गया, ठीक है। लेकिन किसी चीज का दाम अगर रहता है 8 रुपया और आप उसको प्रेडिक्ट करते हैं 10 रुपया, तो एरर कितना हुआ? एरर हो गया -2। लेकिन एरर जो है हमारा वो कभी भी माइनस में नहीं आना चाहिए, इसीलिए देखिए यहाँ पर स्क्वायर किया हुआ है, स्क्वायर। तो क्या कर देगा? वो नेगेटिव को पॉजिटिव कर देगा।
So can you repeat this once more?
This is actually the cost function. Cost function means actually the error, the function which finds out the error. Since if the actual value is suppose 10, okay, and you predicted this as 12, okay, so actual minus prediction, what is the error? The error is 2 rupees, minus 2 rupees, right? 10 minus 12 minus 2. Okay, and see if the value is 10 and if you have predicted suppose 5, so 10 minus 5, the actual value is 5. So this is a positive one. But so previous case that we are getting a negative answer, so negative answer is not going to work. That's why we have put a square over here. So this cost function is basically 1 upon 2m. 2m is 1. What upon 2m? What is this m? M is the number of data points. So 1 upon 2m summation from I equal to 1 till m h theta x of I minus y theta I, y of I whole square. Okay, h theta x of I minus theta 0 plus theta 1 xi. Okay, this is actually the minimizing. Okay, the minimizing.
So basically we are calculating error.
Yes,
minimizing error because we have to predict high.
Yes, you have to predict to the nearest. We need, see, this is actually I'm saying this is basically 1 upon 2m summation from I equal to 1 till m h theta x of I minus y of I. This is actually the error. Got it? This is the error. So this error is actually, see, it is stored inside j of theta 0 plus theta 0 comma theta 1. Means we need to minimize this j theta 0 theta 1. This j theta 0 theta 1 is actually the cost function, or we can say squared error. We need to minimize this. Okay, the higher we minimize this, the better will be our prediction. Got it?
Okay, sir. Got it.
Now, is this clear to everyone or not? Please tell me. If it is not clear, then it will be very difficult. Tell me, is it clear to everyone?
Yes sir, clear sir.
Okay, so we need to minimize the error. The moment we minimize the error, okay, our prediction will get better. Okay, now see, this is actually the prediction line. So the moment we get a minimized, we will get a minimum j. When we get a minimum j means the minimum of j, then we will get this high fit line. See, this actual fitting line. See, idea, choose theta 0 theta 1 so that h theta x is close to y for our training example x comma. Getting the point? So we have to choose, means how to minimize, see, how to minimize j को हम लोग कैसे minimize करेंगे? हम लोग को थीटा 0 और थीटा 1 का वैल्यू को ऐसा चूज करना पड़ेगा कि कैलकुलेशन करने के बाद हमारा एक्चुअल और प्रेडिक्टेड नियरेस्ट है, नियरेस्ट, राइट? गेटिंग द पॉइंट? अभी चलो, लीनियर रिग्रेशन विद वन वेरिएबल कॉस्ट फंक्शन इंटुएशन। कॉस्ट फंक्शन देखिए, कॉस्ट फंक्शन में हमारा जो गोल है वो क्या है? मिनिमाइज जे थीटा 0 थीटा 1। गॉट इट? दिस वाज आवर टारगेट। दिस इज बेसिकली द टारगेट। अब आप बोलिएगा कि सर जे थीटा 0 थीटा 1 ये कॉस्ट फंक्शन है, तो कॉस्ट फंक्शन का फार्मूला क्या है? देखिए 1 upon 2m समेशन फ्रॉम i इक्वल टू 1 till m थीटा 0 x of i minus y of i होल स्क्वायर। इसको कहते हैं स्क्वायर्ड एरर। स्क्वायर्ड एरर, क्योंकि स्क्वायर्ड एरर कभी नेगेटिव में नहीं आता है भाई, इसलिए इसको स्क्वायर किया गया है, इसलिए इसको स्क्वायर किया गया है। ठीक है? गॉट इट?
Sir, I have one question here. So this
Yes.
error minimizing, sir, this we do basically in regression only, or we do in classification also?
No, this is actually the cost function for regression.
Okay, means
Okay.
there is a separate cost function for classification.
Yes, but here, yes, but here we are, see, if you go for classification, there you have to optimize the algorithm. Here also we are optimizing the algorithm, okay, but there is some different method present, different method. Okay, I will tell afterward, don't worry. Okay, got it. I will keep your question in mind, don't worry. But here we are solving a regression problem. So regression problem without cost function, you will not get a good output. You will get output, but that output will not be justified. It will not be considered,
Okay.
because for some value it will give very close, very good answer, but for some value it will give very high answer, very high difference in error. So is that justified? Is it justified? Not at all. Not at all. Okay, so our goal is to minimize this j theta 0. Now see, simplified. See, we have to minimize this j theta 1. If we consider this theta 1, I will considering only theta 1. See, only theta 1. Only theta 1. No theta 0. No theta 0. Only theta 1. So अब h theta x equal to theta 1 plus x. Right? Theta 1 plus x. So if j theta 1 equal to 1 upon 2m, summation from I equal to 1 to m theta h theta x of I minus y 1 of y of I whole square. So we have to minimize this j theta 1. First we minimize this j theta 1. Okay, first we need to minimize j theta 1, then we will minimize j theta 0. First minimize j theta 1. Okay, how to minimize j theta 1? We have to find the partial derivative of this equation. For theta 1, we have to find the partial derivative. See, they have found the partial derivative. We have to find the partial derivative. This is actually called what? See, this is actually means, see, this is actually the prediction line. See, we have to do what? We have to basically do what? We have to basically find out the partial derivative, because if we find the partial derivative, then only we are getting the minimum, right? Right? If you go for introduction in integration, then we are going for maximum.
Yes, sir.
Okay, so here we are going for partial derivative. If we find the partial derivative of the equation, so here j theta 1 is basically minimized, and once we get this output, so we can see that the j theta 1, if we put the value of theta 1 equal to 1, we are getting the value as 0, so it is minimized. See, j theta 1, it is minimized at I equal to 1, j equal to 1. See, no, we have to find the minima. We have to find the minima. Okay, you are absolutely right, Arvind. You are telling by using partial derivative we can get maximum and minimum both. You have to work on minimum. Okay, minima, maxima you don't have to do. Minima. Okay, Arvind, minima. You have to find out the minima. Clear? Now similarly, see, a value is put 0.5, and here the equation is actually solved, and we are getting output something like equivalent to 0.58. 0.58. So we see we are getting something like this. The next one. Okay, here theta 1 value is 0.5. Theta 1 value is 0.5. Okay, theta 1 value is 0.5. And now we are getting output something like 0.58. Now you see, similarly, we build a graph something like this. This V-shaped. See, this V-shaped. Just have a look. This V-shaped. So now, here in the PPT, it is written that to minimize j theta 1, and we can see that j theta 1 is minimum at theta 1 value at 1. If the theta 1 value is 1, then j is minimum, right? If the value of theta 1 is 1 equal to 1 on x axis, then definitely we are getting minimum j. Yes or no? We are getting minimum j.
Yes.
We are getting minimum j. Okay, getting the point. We are getting minimum j. Now this is actually the V part. This is actually the V part. Okay, so now if I said that suppose you are standing at this blue cross at 2. See, y-axis 2. On y-axis 2 there is one blue cross. Can you see, everybody? One blue cross is there. So suppose Darshan is actually standing on this blue cross. Okay, or Arvind is actually standing on the blue cross, right? This blue cross, and Arvind is actually blindfolded. And if we tell Arvind to move to this one means where theta equal to 1, to this minimum error, because this is the place of minimum error, where theta equal to 1 on x-axis. So if we say, Arvind, to move, that you are on the top of a hill where the blue square, where the cross is actually blue, and Arvind is actually standing over there. So if you tell Arvind, please come down from the hill, you are blindfolded, you come down to the hill, and okay, and you reach the point of minimum error, means that point at 1, the point at 1, or near about 1, or near to 1. Okay, what do you think? How Arvind will move down? Definitely he will look for the descending ground. Yes or no? He will look for the descending ground. Yes or no? Tell me. Because he is moving from top of a hill. Right? He'll move from the top of the hill, right? Okay. And will he take smaller steps, or will he take bigger step? Will he take smaller step or bigger step?
Sir,
smaller step. बड़ा step लीजिएगा तो सामने की तरफ आप गिर जाइएगा ना.
Sir, I have one doubt, sir.
Yes, tell me.
Sir, if there is a minimum curvature where the theta is 1,
Yes.
the value of theta is 1.
Okay.
If there is some other curvature are there, local mean.
No, you cannot take other curvature. I'm telling, yes, because here we are finding the local minima, na? Minima. Okay, and for minima,
Yes, sir.
we get only this curvature, Rohit, I think.
Sir, if there are 2 or 3 curvatures.
If there are 2 or 3 curvature, okay, then this formula is not applied. Then to that, this formula is not applied. Getting the point, Rohit?
Sir, why, sir?
No, this is not applied. See, if there is, see, I'm telling you, this is actually, I'm telling you, this is actually starting only. I told this is linear regression with one variable. Okay, that means there will be one input representing x, and there will be one output which is represented by y. So if we consider y, then definitely we are going to get this curvature only. If you are planning for some other curvature, then this formula will not be applicable, and for algorithm optimization, neither this what to say, the actual hypothesis theta 0 plus theta 1 x will be applicable. That will also be not applicable, and this j we are going to minimize j na, j theta 0 theta 1, so this one is also not applicable. Got it, Rohit?
Yes, sir. Okay, sir.
Because this is actually a linear regression using one variable. So in one variable we can get only this concave. You cannot get convex. Convex you cannot get, concave pabo na, concave. Right?
Yes, sir.
Okay, getting the point. So here we are getting concave. Yeah, concave. So just have a look. So if you want to remove move here, so here if what to say, Arvind is actually moving to this one, which is the place of minimum error. He will take smaller steps. So here this smaller step is basically called learning rate. What it is called? It is called a learning rate. It is called learning rate. Learning rate. It is called learning rate. Okay. So Arvind will take smaller steps, smaller steps. Okay, and these steps are actually called what? These steps are called number of. So this step is called learning rate. And how many steps he will take? He has to take multiple steps. Multiple steps. It can be 500, 1000, 2000. Any steps he can take. Okay, so that is actually called a number of iterations. Iteration. And each time we are actually doing what? Each time our error is getting minimized because we are trying to find out the partial derivative. We will get the same curvature using linear regression using one variable each case. Yes, Arvind. Yes, you will get the same curvature. Linear regression using one variable or univariate. Got the point? This is a single variable, na? Only x-axis and y-axis. So this curve is will only get, na? Okay. Now, so once Arvind reaches this point 1, this is the point where we have the minimum error. Okay, or even if he reaches 0.5, even if it is not possible for him to reach 1, suppose, and even if you retest 0.5, then mostly his error is minimized. To most extent, his error is minimized, because we know machine learning algorithm we cannot get 100% accuracy. We know that. Getting the point? Last algorithm also we didn't get 100%. We get 96%. Okay. So this is
Sir,
basically the curvature, and this algorithm is basically called what? It is called gradient descent algorithm, which is actually a optimization algorithm for simple linear regression. Optimization algorithm for simple linear regression. That's it. Yes.
What is the
Any
name
doubt?
of this algorithm?
hello, sir. Hello,
Gradient
sir.
descent. Gradient descent.
Sir,
Name of the algorithm is gradient descent. Gradient descent.
hello, sir.
Yes, Rohit.
Sir, in our data set, there are many columns are there. We are
Huh.
taking these columns as a input, and
No,
sir,
see, Rohit,
yes, sir.
if we are having multiple columns in our data set, okay,
Yes, sir.
so that is actually regression using multivariable.
Multivariant regression.
Yes, this is univariate, na? Univariate. One input, one output. Because y equal to mx plus c. X is the input, y is the output. So one for x, one for y. Univariate.
Okay. So sir, ID's data set is multivariate.
Irish data set is to actually it is classification problem.
Classification.
Classification we cannot
Oh,
classify
acha,
na
acha, acha.
multivariate,
Yes, yes,
univariate.
yes, yes. Yes,
Regression
yes.
problem is classified na regression problem.
Okay, okay, okay. Sir, got it, sir,
Okay.
got it.
I showed you the salary data set, salary data. That salary data. Okay. Salary data.
Yes, sir, the salary data. Yes, sir.
See, now linear regression with one variable, cost intuition function 2. Okay, see, hypothesis. This is actually the hypothesis. So we said our task is actually minimizing of this. This is actually the goal, right? Everybody knows that. This is the goal. Again, I have repeated this. This is the goal. Now next, see, here the curvature is made something like this. Here the curvature is made, and our task is to reach this point theta 1, theta 1, theta 1. Means we have to minimize this theta 1 to such an extent that our cost function gets minimized. Our cost function gets minimized. See, if you don't minimize our cost function, we are getting a line something like this. See, if you don't minimize our cost function, we are getting line something like this. Do you think this black line is a correct prediction line? Is this black line a correct prediction line? No, no, this is not a prediction line, because the prediction line is not at all passing through the data points. This prediction line is not at all passing through the data point. This prediction line is not at all passing through the data point. Okay, this prediction line is not at all passing through the data point. So this is actually not at all the correct line. Okay, now this is actually the 3D model, 3D contour figure. We don't require this. Still it is given. I have given this, not required. The 3D part. This is actually the 3D part. Means you are standing on the top of the hill and you have to move at the plane. Okay, this is actually the 3D model. See, we have to reach this dot. We have to reach this dot, and we are standing where? We are standing at this cross. Okay, so once we start minimizing this, we will move closer to this dot. We will move closer to this dot. We'll move closer to this dot function. Okay, to this dot. So our task is to move closer to this dot. From this cross, from this red cross, we have to move this closer to this red dot. Okay, this is actually the thing, and this is how done. It is actually done by minimizing the theta 0 and theta 1. So this is actually shown on the training example. Actually on the training example. Okay, so if I said that this is also repeated, like if theta 1 is 0, then it will get some straight line. This is also not valid. Okay, this one is also not valid, but this one is actually valid. This one is actually valid, na? This one is actually valid, right? This is a valid line. Means it is trying to pass through the data points, and the horizontal line from the data points to our prediction line are basically those errors. See, the horizontal lines, this blue horizontal arrows. See, this blue horizontal. See the left diagram. The blue horizontal arrows from the data points to this blue line are basically what? These are our prediction lines. These are our prediction lines. These are our prediction lines. Getting the point? Okay. These are sorry, extremely sorry, not our prediction line. This blue. Wait. Yeah, this blue line is actually our prediction line, and these blue small arrows are basically the error. So we need to minimize this error. How to minimize the error? If this line passes very well through the data points, our error will get minimized. Okay, so let's start linear regression with one variable, gradient descent, basically gradient descent. The same task. Hopefully we end up at the minimum j. Our task is to end up with the minimum j or minimum j. Okay, 3D value not required. See. Excellent. So where we were standing? See. Awesome. Very nice. Just have a look. See. Again. Automatically it will take C. So our error is getting minimized. The best path it is choosing, and our error is getting minimized, right? Okay. So from the top of the hill, we are moving to this path. Now just have a look. Awesome. See. Minimum error. So how we minimize this basically? See. Repeat until it converges. Repeat until convergence. Shilling repeat until convergence. So gradient descent algorithm. If they have considered, okay, or we have considered temp of 0 equal to theta 1 and temp 1 equivalent to theta 0 and theta 1. See, temp of 0, theta 0 means temp of 0 and theta 1 means temp of 1. So this is basically the formula. And this alpha is actually the learning rate, Alpha is actually the learning rate. So see, okay, d by d theta 0, j theta 0 theta 1. Okay, now alpha. Now again see, for temp 1 theta 1 minus alpha of d by d theta 1 j theta 0 plus theta 1 theta 0 comma theta 1. Right, this is the thing. Gradient descent again. See, alpha is actually the learning rate and this thing is actually the partial derivative. See, now I hope partial derivative is very easy. It is not that tough, isn't it? एक वेरिएबल को धर पकड़ो, एक वेरिएबल को पकड़ के डिफरेंशिएट करो, फिर दूसरा वेरिएबल को पकड़ो, दूसरा वेरिएबल को पकड़ के डिफरेंशिएट कर दो. यही तो पार्शियल डेरिवेटिव, यही है तो. अरविंद, दर्शन, रोहित, ठीक बोल रहे हैं तो हम?
Yes sir. ठीक
है. पार्शियल डेरिवेटिव एक बहुत सिंपल सा सम है. ठीक है, हमारा फिंगर टिप्स पे हम लोग इजीली कर सकते हैं इसको. ठीक है, वेरी इजी. नाउ सो देखिए, सो दे आर टेलिंग दैट थीटा 1 के लिए देखिए हमारा यहाँ पर क्या मिला, पॉजिटिव नंबर मिला, और यहाँ पर हमारा देखिए क्या मिल रहा है, नेगेटिव नंबर मिल रहा है. तो नेगेटिव स्लोप मिलेगा तो कुछ इस तरीके से मिलेगा. ठीक है, ये हमारा नेगेटिव स्लोप मिल रहा है, राइट. नेगेटिव स्लोप मिलेगा तो हमारा कुछ इस तरीके से मिलेगा. ठीक है, बट अल्टीमेटली क्या हो रहा है, देखिए हम अपना जीरो मतलब मिनिमम एरर की तरफ बढ़ रहे हैं. ओके, मिनिमम एरर की तरफ बढ़ रहे हैं. सी, इफ अल्फा इज टू स्मॉल, ग्रेडियंट डिसेंट कैन बी स्लो. अल्फा अगर बहुत ज्यादा स्मॉल हो जाता है ना, तो ग्रेडियंट डिसेंट स्मॉल हो जाएगा, मतलब ये हो जाएगा, स्लो हो जाएगा. और बोल रहा है कि अगर आपका लर्निंग रेट जो है वो बहुत ज्यादा हुआ, मतलब आपका स्टेप्स बहुत ज्यादा हुआ है, तो ग्रेडियंट डिसेंट कैन ओवरशूट द मिनिमम, माने वो मिनिमम को स्किप कर जाएगा. स्किप कर जाएगा मतलब वो फेल हो जाएगा, राइट. ग्रेडियंट डिसेंट विल फेल. तो व्हाट शुड बी द वैल्यू? इसका वैल्यू जनरली क्या होता है, 0.1, 0.01, 0.001, समथिंग लाइक दिस. बस, इससे ज्यादा हम नहीं ले सकते. 3-4 वैल्यूज है, इससे ज्यादा हम नहीं ले सकते. मैं दिखा दूंगा आपको कैसे क्या करना है. ओके, सी, रोहित यू आर टेलिंग ना, लोकल वैल्यू, लोकल मिनिमा.
Yes sir, I am telling that.
Yeah, see, okay, so this is actually the approach for a local minima. We approach as a local minima. Okay, so gradient descent will automatically take smaller steps, so no need to decrease alpha over time. So gradient descent for linear regression, again the same thing has been repeated, right? See, as you can see, we are finding the minimum of it. If you differentiate this, you will going to get something like this. So differentiation is very easy. I hope you can find out on pen and paper if you want to do. But here in programming, we don't need to find all these things, because in programming also we can do all these things. Okay, all these functions are basically available, right? So shall I start the programming?
Yes, sir.
Okay, so I'm starting the programming right now. So just have a look. I'm just minimizing this. Okay, I'm just minimizing this. Started Jupyter. I've started. Okay, where I have the salary data. This is the salary data. Years of experience, salary. Years of experience, salary. Okay, so this data set I'm going to work with. Okay, I will work with this data set. Now, first of all, what we are going to do? First of all, we are going to read the data. This is a very simple. Okay, so we are going to work with linear regression. This is simple linear regression. Getting the point? Simple linear regression. So I just write this code and I just read this data set. See, data set is read, and here I will find data dot first shape. Oh, data set dot shape. Clear? Just have a look. Just have a look. Data dot describe. Okay. Data info. Dataset dot info. Dataset dot info. Dataset dot info. Okay. Now I have to divide the data set into the means I have to split the feature from the target. Okay, so here I have written something like this. The feature, this is actually the feature. If you want to print M, you can see dot head. This is actually the feature. Okay, and n dot head. This is basically the target, right? Just have a look. Feature and the target. If this part is clear, then only I will shift to the next part. Please tell me, because if this part is not clear, then it will be quite difficult. Just have a look and please tell me. Now machine learning is going to be very easier. Data science is going to be very easy. It's clear. No, it is very easy. So here we have divided the data set into training and testing part. Okay. Now I will import plt.scatter plt.scatter m comma n, okay, and plt.show and plt.xlabel X label, what it will be? It will be X will be experience. plt.y label experience, y level will be salary. Okay, so see, very nice plot we are getting. Excellent. See, very nice plot. Excellent. Data visualization is a part of data science, I told. Okay, now I will split the data set. I will basically split the data set into the training and the testing part. Okay, I will split the data set into training and the testing part, right? So see, the same code. Is there any difference between whatever I showed in the first half and whatever I showed in the second half? Is there any difference between the two? Only I have taken the
Yes.
it's I have taken it on m and n. In the previous class I have taken on x and y. That's why I have passed n and n. I have divided data set into 0.2. 20% is the testing part and 80% is the training part. Now some might be wondering, sir, why only 80 and 20? See, 80 and 20 is the best means what to say, best cross validation means ratio, best cross validation ratio. If you want, you can divide it into 75-25 or 70-30. 75-25, 70-30. 75-25, 70-30. Right? No problem. So previously I built the model and now I have to build the model basically for linear regression. See, from sklearn.linear_model import linear regression. और यहाँ पर देखो हम लोगों ने मॉडल बना लिया है. वहां पर क्या था? sklearn.nearest neighbor import k nearest neighbor. Remember? And here the package name is from sklearn.linear_model import linear regression. और here we have built the model, fit किया है x train, y train. Now lr के अंदर मॉडल है lr.predict. प्रेडिक्ट किसको भेजेंगे हम लोग? एक्स टेस्ट को भेजेंगे. एक्स टेस्ट को भेजेंगे. ओके, और एक वेरिएबल ले लेते हैं प्रेड बोलकर एक वेरिएबल ले लेते हैं और यहां पर हम लोग काम करते हैं, प्रिंट कर देते हैं प्रेडिक्ट को. प्रिंट कर देते हैं प्रेड को प्रिंट करेंगे ना. लेट्स प्रिंट. सी गेटिंग द आउटपुट. सी आई एम गेटिंग द आउटपुट. हियर आई एम गेटिंग द आउटपुट. ओके, हियर आई एम गेटिंग द output, but I need to compare the output with the actual value. Where is the actual value? The actual value is inside what? It is inside y test, right? It is inside y test. Actual value is inside y test, right? So I will convert. See what I am doing. It is inside y test now. So I have written a code something like this. See, a code. pt.data frame actual. This is actually the actual is the y test. This is actually the prediction is inside this pred variable. Okay, and this is actually y test minus pred. This is basically the error. Okay, if I run this code, see, the actual salary was 1,12,635 and the predicted salary is 1,15,790. the error is around 3,155. Actual salary 67,000, predicted 71,000. Actual salary 1,13,000, predicted 1,02,000. Actual salary 83,000, predicted 75,000. Actual salary 64,000, predicted 55,000. Actual 57,000, predicted 60,000. So the error is near about how much? See, sometimes it is giving the error like 3,000, something it is giving 11,000, something like that. Okay, something like that. Getting the point? It's giving the error something like that. Now I will do one thing. I will find out here the mean squared error. Remember 1/2m summation from I equal to 1 till m h theta x minus y whole square. That is actually called mean squared error. तो भाई स्क्वायर्ड एरर इसका कितना है? इसका मीन एरर कितना है? मीन माने एवरेज एरर ये कितना दे रहा है? कितना एवरेज एरर दे रहा है हमारा? ये जो है एवरेज एरर दे रहा है 7,059 का एवरेज एरर है इसका, हमारा मॉडल का. हमारा मॉडल का एवरेज एरर है 7059, ठीक है, बहुत ज्यादा है एरर, एरर इज वेरी हाई। तो एक काम करते हैं, यहाँ पर हम लोगों ने क्या किया था, 0.20 किया था, थोड़ा सा डेटा सेट तो बहुत छोटा है, 0.1 करते हैं, 1, ओके 1 मतलब 10% हम लोग ले रहे हैं ट्रेनिंग में, 90% ले रहे हैं टेस्टिंग में, सॉरी 90% ले रहे हैं ट्रेनिंग में, 10% ले रहे हैं टेस्टिंग में। ओके लेट्स सी क्या आउटपुट मिलता है, एरर कम हो रहा है या नहीं। देखिए एरर कम हुआ थोड़ा सा, 6988, मतलब हमारा डेटा सेट भी बहुत छोटा है। ओके डेटा सेट भी बहुत छोटा है, तो हम लोगों ने ट्रेनिंग में बहुत ज्यादा डाल दिया है, टेस्टिंग में बहुत कम किया है। टेस्टिंग में मात्र 3 डेटा है हमारा, देखिए 3 डेटा है हमारा, राइट। अब मैं काम करता हूँ, थोड़ा सा मैंने यहाँ पर एक काम करता हूँ, ये जो है बहुत कम हो गया। और अब मैं रैंडम स्टेट को थोड़ा चेंज करके देखता हूँ। रैंडम स्टेट को मैं पहले 0 करता हूँ, 0 मतलब रैंडमली डिवाइड नहीं होगा डेटा सेट। लेट्स सी, ओह एरर इज सो लेस, सी एरर कितना कम गया देखिए। तो रैंडमली हम लोगों ने इसको डिवाइड नहीं किया। ओके इसको 1 में करके देखता हूँ, 1 बार बार शफल होगा, देखते हैं। नो बढ़ गया, तो इसको 0 ही रहने देते हैं, लेट इट बी 0, लेट इट बी 0। ओके सो दिस इज माय एवरेज एरर, नाउ इट्स ओके ना, एवरेज एरर, नाउ इट्स ओके ना, एवरेज एरर।
So this mean square error is your cost function, right?
Yes, that's cost function, yes.
And so why you did the
Yeah, this is the error. I found out the error. Squared error.
So why you doing the square root? Square root,
Yes.
why you doing the square root? SQRT?
Yes, I have given the square root. Yes. Here I have found out the mean squared error. Okay. Here I have found out the mean squared error. Okay. In linear regression, you basically find out the mean squared error. That's why I have given here square root basically. Okay. I have given here square root. Remember that square here is not given. Square is not given.
So that cost function formula 1 by 2m.
Yes.
That one.
Yes. Here mean squared error is actually tells us how close a regression line is to the actual data means value. How close our regression line. Regression line is the prediction line, na? Means how close our prediction line is to our actual data value. To our actual means the actual value. Getting the point? It is actually the measure of the amount of error. Measure of the amount of error. We basically find it as a mean squared error. Getting the point? Okay. Root mean squared error basically. Yeah. Root mean squared error.
Yes, sir. That is RMSC basically.
Root mean squared error. Not mean squared error, root mean squared error. Okay?
RMSC.
Yeah. So now we have to use a gradient descent. Now we have to use gradient descent. Because if we don't use gradient descent, then how our error will decrease? How our error will reduce? Because gradient descent is an optimization algorithm of regression problem, right? It is the optimization algorithm, I said. Remember, optimization algorithm. Optimization algorithm. So gradient descent formula, see, you will not get anywhere in Python. In Python, you will not get that any method for gradient descent. Gradient descent, you have to look at the formula and you have to implement it. Okay, see, I have implemented it already because it takes a lot of time to implement. I've taken the value of m0, c0, learning rate 0.01, epochs 1000, n equal to float length of x for I in range of epochs. Okay, y equal to mx plus c, m grade. This is the value of m, this is the value of c. We have found out the value of m and c every time and printed the c. Means actually I found out the partial derivative. The same thing I've done, partial derivative. Here is actually the equation y equal to mx plus c, and we have found out the partial derivative on it. C. And if I run this, I can. What happened? Acha, x is not defined. Oh, x. Here we have to define x and y. See. Okay, here I have divided the data set into m and n. Na? Okay, one more thing I am telling you, I will create one more cell over here. I will copy paste the whole thing. I will copy the whole thing and I will paste it over here. Huh? And this I will store it inside x, and this I will store it inside y. Same thing inside x and y. And now it is load, run this, and now I can. What happened? Integer to string. Why? Oh, I have to use that iloc function there. That's why it is telling. Okay, ilog function, ilog. Okay. ilog function I've used. So I will take the 0th column and here I will take the 1th. Okay, not in the array form, something like this. Now it is okay. Let us see here we are getting a value of m and one value of c. See, can we minimize this? Wait, 0.00. If I take 0.001, then can we minimize this? 9,501 was the value. 11,760. It is increasing. If I said 0.1, will it increase or decrease? It's telling none, NN. So 0.01. 9,501. If I increase the number of iterations, suppose 1200, then 9,471. Okay, I will take it to suppose 1500. Then 9,456. Oh, it is not going to give something like much more. Okay, I will take it to 1500. Otherwise, it will grow slow. 1500. Okay, 9,456. Okay, chalo, done. Yeah, my come
So
complete.
x and y you have taken 0, 1, x, y in the above. X, y.
What? X and Y.
So, yes, sir. Can you show x and y once? What is x and what is y?
Which one? Where?
Sir, above. Below m and n, which you have taken a target and you have copied.
Yeah, this one, na. So,
So
finish
why
your
you have
zeroth column and 1th column.
Sir, but here to m and n and x and y are both the same. So why you have taken 0, 1?
No. I printed two things. See, here when I type the see, when I find out the type of m, what it is telling, it is actually in the form of data frame, right? Data frame.
Yes, sir.
So data frame it is, na. And here when I find out the type of x, see, it is telling it's a series. Series is a single column. Data frame is actually see, data frame is also, if you want to represent a single column in data frame, that's okay, but it is in data frame, means it's in a frame, it's in a tabular format. And if you want to represent something in series, that is also okay, means there also single column is represented, but in the series format. So see, this is the difference, data frame and series. So we want to input a series over here, series, otherwise it will not be interpreted. In mathematical formula, always you have to insert a series, not data frame. Okay.
Okay. Means 0 for the first column and y for the okay.
Next column.
Okay.
Yes. No problem. Very good. Now let's move ahead. Let's move ahead. Let's move ahead. Let's move ahead. Basically, just have a look. Let's move ahead. Just have a look. So we are here. We have got the minimum of what to say. I found out partial derivative, and here we have got the minimum of m and c. Right? The last formula is clear to everyone. Is it clear to everybody? The last formula.
Sir, m is basically the slope or the coefficient and c is the
Yes.
intercept, right?
Yes.
Okay, sir.
No
So
problem.
this formula basically is calculated from the gradient descent formula you have done.
Exactly. This is actually the gradient descent formula itself. This is the gradient descent. I have implemented gradient because in Python there is no function for gradient descent. So I have implemented gradient descent also.
Okay, sir.
Okay, that's it. Now let's move ahead. Now the same code I have copied over here. Y equal to mx plus c. This is actually the formula, na? Now if I run this, what happened? Oh, m multiplied by x. What happened? Int object is not iterable. Why? Founded the value of m, founded the value of c. Now what?
This code is basically our code only. Means you have copied.
Ha, so here why I have copied, because I have founded out the value of actually what to say, m and c, na? So I have shifted it. I have shifted y parade equal to mx plus c. I have shifted over here. I have the same code, na? This is the same code, this one. Okay, the same equation. So here I have got a new value of m and new value of c. So that I have shifted over here. And we have x. Where is x? X is actually the input. Here is x. Here is x. Okay, and we are going to find out this y parade. So if I just print here, will I get output? Yes, I'm getting the output.
But all the outputs are none.
No, I have to modify, na? I have to modify. The actual value is basically inside y test, and the predicted value is inside y parade, and the error is basically y test minus y parade. I have dropped na value, okay, and I have showed here. What is the problem, Ravi? What is the problem?
No, sir. The after means y predict, which you have calculated using mx plus c. Sir, if y predict, all the values are showing to none. Just now, which you have printed, all are showing to none. Y predict, all the values are showing none. Actually,
Okay.
just now you have printed y predict. So in that only I saw.
But there is some problem. I will start from the run all. I said na, nothing was a problem. I think I have run this x and y multiple times. That way, see. Let me find out the, yeah, that's it. See, that's it. Just have a look. Got it? Now let's move ahead. Here, the error was basically 2000 for first one. See, the error was actually
hello.
2897. And here the
Sir.
error is basically 2204. Yeah, yes.
Sir, what will be the value for y equals to mx plus c? There will be a single value, right?
Why there will be a single value? If why if the value of x is 10 times, means there are 10 values of x, then there will be 10 value of y period, na?
Then there should be a different column for that one.
We are having, why we are having, yeah, we have different columns. See, y period is actually stored inside prediction column. I have different column.
Oh,
I am having different column. Actual is actually what? It is actually given, actual is given in the data set. See, actual is the one from the data set. What does it have? It have the ID 2, na? 37,731. 2. 37,731. See this one. 37,731, right? This is the actual data. If this year experience is 1.5, salary is 37,731. Okay, 37,731. What is our prediction? Our prediction is 39,935 after using gradient descent. So error is reduced to 2,204. Error is reduced to 2,204. 2,204.
I have one question. So why you have done drop any means for dropping the null value, but here means whether null values will be there.
If I just don't drop this null value, okay. See, I'm dropping this. See, for testing it is giving the answer, na? For testing, but for training it will be an n, because for training it is not giving the prediction, na? Training it will be an n.
You have
Getting the
taken
point?
0. You have taken 190%.
Yes.
So 10% it will show.
Yeah.
Got it.
Getting the point? So here is our prediction, and further this model cannot be increased. I have seen all the things. Okay, so see, the first here the error was actually 2,897. It has been reduced to 2,202. But for the second, the error has increased. See, it was 761. Here the error has increased to around 7,400. For one, it has increased. But again, see, for the next, it was decreased. Next, see, the error was actually 7,930. So high for 13 number. So high error was. Okay, now see, the error has reduced to 757. 757. Yeah.
So, sir, we can say that after the gradient descent also, error is not means we cannot say that it is reduced because
No.
for
Yes,
13
yes.
it has been increased.
Yeah. This see. After using gradient descent, you will get massive result, massive, very excellent result. But just have a look at the data set. It has got only 40 records. Only 40 records. In this 40 record, if it has been 4,000 record, na 4,000 record, our model would have given the best solution, best solution. Okay, but it
Because
has
of the
seen
less data
only
set,
30, not
less
40
value.
record. Oh, Baba, wait, Darshan, only 30 record, Darshan, only 30 record. 30 record. This data set I have made of my
Because
own.
of
You
the
can
less
take,
value.
yeah, you can take any data set, salary data set from the internet, and you can start. So this is a very simple small data set. I performed on a small data set. If you take a data set with having around 1,000 for 2,000 data, na, so this code only, don't have to make any changes. This code will give you around, means a very good accuracy, around 90 to 95% accuracy. Getting the point? It will give the best accuracy. This is the highly efficient algorithm. This is the most efficient algorithm. This one, most efficient algorithm. This one. Getting the point? The most efficient algorithm, gradient descent, that is used in linear regression. So I did 2 examples today. Is it clear? Is this clear to everyone?
Yes, sir. Sir, after this, how we will check the accuracy? Means after gradient descent?
No,
Differentiation is
Darshan,
accuracy.
in linear regression you cannot find the accuracy. In simple linear regression using one variable, you cannot find the accuracy. Here, that's why I am finding the error, na? That's why I'm finding the error. Here you have to find the error, not accuracy.
Okay.
Getting the point? Continuous, na? Regression is continuous, na? How you will find the accuracy?
Okay, means for regression we have to just predict the values.
Yeah. Now, shall I start the prediction? The prediction started. Shall I give the prediction graph?
Yes, sir.
Okay, because until and unless you give the prediction graph, na, means it is not, means what to say, not valid. I said we are in a data science, huh? In data science, if you don't give the prediction graph, na, that is, see, we got the prediction line, but if you don't give the prediction graph, it is not at all valid. It is not at all valid, you know. It is not at all valid. Okay, it is not at all valid. So this is basically the prediction. We have got the prediction basically. Okay, we have got the prediction, and after getting the prediction, here I will give you the prediction line. Okay, so this is actually the thing here. This is, I'll just write the code over here so that it is, if you don't write, then no problem. Okay, plt dot scatter x comma y, is it giving the graph? Yes, very good, it is giving the graph. Fine. Now plt dot plot mean of x comma max of x, mean of x and max of x. Got it? Mean of x, max of x, and mean of y, mean of y pred, max of y pred. Okay, okay, chalo, that's it, no problem.
No, sir.
Okay, so this is actually the example for today, and wait, I'm sharing this in the WhatsApp group. Just a second, give me some time, please. Wait. Okay, just a second. You study this Python tutorial.
So can you share the PPT also?
This PPT, okay, actually see, this PPT actually belongs to the company. Okay, it solely belongs to Ardent
Okay,
Computing.
sir. Okay, sir.
Okay, so yeah, I will take the permission from Ardent, okay, company, then I can share. Okay, so if they tell yes, then definitely I will give it to you. Okay, but basically this is for study purpose. Okay, yeah, I will share some other PPT to you. Okay, that will be in a better format. Okay, more explainable format. Okay,
Okay, sir.
okay, okay, don't worry, don't worry. Yeah, yeah. Anything else?
And sir, recordings. So actually, yesterday recordings,
See,
I think so.
I had a talk. Yeah, recording. Yeah, recording. It said that you attend all classes. Okay, recording you will get at the end of the means what to say the session. End of the session you will get recording. All your recordings
Okay,
together.
sir.
Okay, I had a talk. I had a talk.
Okay, sir.
Okay, don't worry. You will get everything. Study materials. Wait, I'm sharing the data set also. I made one mistake. I must share the data set. Okay, Irish data set and this. Yeah. I'm sharing the data set also. Just a second. Irish data set. Okay, and salary data set. Salary data set. This is the salary data set. See, I've shared you all the resources I've shared. Okay. Okay, see, I have got a very a very big what to say, a chapter. But this simple linear regression, this is highly means very big. Okay, so shall I send this? It has got around 80 pages. No, apart from that, lots of other things are also written in this. Okay, and lots of things
So
are
like
basically written.
mainly, sir,
Yeah.
you have done with one variable, one feature and one output. Means the next step later you will do with multiple features.
Yes, multiple feature I will show you. If you want to see, then I will show you. Otherwise, I will start some other algorithm. See, it is also very easy. Multiple. I will show you. I will show you with multiple features. Okay, don't worry. I will show. First, I will show that one, and then I will show decision tree and random forest. Decision tree and random
Okay.
forest. Okay, decision tree and random forest. I will show you. Getting the point? Decision tree and random forest. Next day, our target is at least 3 algorithms. 3. See, decision tree, random forest, it will not take much time, but our minimum target is 3 algorithms. One is the same using multiple variables, and the other one is using decision tree and random forest. Okay, wait, let me take the attendance.
Sir, one doubt, sir.
Yes, yes, please tell, please tell.
Sir, if there is many columns, sir, and if we are given that we have to compare three columns, whether 3 or 4 columns, whether they are having a duplicate value and all, how we can find?
Very simple, I'm telling you. See, using the ilog function, you store all those columns into a variable. Got it?
Okay. Okay.
And suppose you store all these things inside the variable, okay, a,
Okay.
and in the next line you do a dot drop duplicates. That's it.
So drop duplicates
Yes,
means
drop underscore duplicates. There is a method. Drop underscore duplicates.
Means the
You
column
said
which are
duplicate.
having duplicate values, we will
Yeah,
store in one variable.
yeah, yeah. Duplicate rows will be removed.
sir, from
But
comparing from 3 or 4 columns.
Whatever column you want to compare, you have to, using the ilog function, you have to store the whole thing inside a particular variable. Okay, particular variable. After that, you apply the drop duplicate method on that particular variable. So again, it is locked. Okay, but this is never done. The question is bit wrong, because we never drop duplicates for a column. Basically, duplicates we basically consider or drop using the rows. Rows are actually our data, na?
So basically, I am trying to find how many how many percentage of columns are same with the other columns.
Hey,
Means
Babare, no. See, Rohit. This is
okay,
actually, yeah, this is actually a disadvantage. I said that two columns should not be correlated. If the two columns are correlated, now you can simply found out the with the core function itself I told yesterday. And if they are correlated, then you have to remove that. You have removed any of the one of the column. Okay, if they are same, then they are not going to give a good model.
yes, sir, yes, sir.
Okay,
So,
if
sir,
these columns,
how I can compare 3 or 4 columns whether they are correlated or not?
yes, see, I use that core function, na. So core function is basically CORR. Inside variable which you have stored the data set, that variable dot CORR. Okay, I showed you the correlation. Once you use the
Yes, sir.
correlation, it will give the correlation for all the columns, na. Those who are having numerical columns. Suppose if there are
Yes,
50
sir.
numerical column, it will give a correlation for 50 numerical column. If there are 20, then 20, then 5, then 5, 1, then 1. It will give. Getting the point?
Yes, sir. Yes, sir.
So
and
this is
what
basically
does
the
heat map do? Heat map also correlation, right?
hello.
Heat map,
Is null. No. Is null is actually
heat map,
removing if the
heat map,
yeah.
heat map.
is null. ISNULL.
Sir,
Yes, sir.
heat map. He is telling heat
Heat
map,
map.
sir.
राइट डाउन स्पेलिंग लिखिए तो दर्शन, एक बार स्पेलिंग तो लिखिए तो। चैट में लिखिए तो स्पेलिंग तो। राइट डाउन द स्पेलिंग इन द heat map. Heat map. See, heat map is actually the graphical representation of the correlation.
Okay.
Heat map. Okay. Graphical representation. Graphical representation. Getting the point? It is the graphical representation. Clear? Darshan, is it clear?
Yes, sir.
Okay, so this is basically the thing. Okay, it's a two-dimensional representation. Basically, colors are used in this. Okay, chalo. Okay, Anusha Bera. MD Zad Siddiqui. Shrestha Poddar.
Yes, sir.
Okay, Srishti Bose. Srishti Bose. Srishti Bose. अच्छा एब्सेंट। अच्छा आदित्य नारायण दास। आदित्य नारायण दास एब्सेंट। भाबातोष सरकार
प्रेजेंट सर।
प्रेजेंट। अच्छा बुधा बुधादित्य
प्रेजेंट सर।
okay Aditya Narayan Das is also present. Okay, Budha is also present. Now Devopom. Na wait Debojyoti Saha is present. Okay, Devopam Das present acho Devopam नहीं। अच्छा दीपान दीपान खटुआ तो আছে প্রেজেন্ট আছে আছে আচ্ছা আচ্ছা দীপায়ন খাটুয়া তো নেই। আচ্ছা দীপি রঞ্জন রাউত
স্যার।
ওকে ইমান কল্যাণ তো নেই। কৌশিক দেবনাথ is present. Okay, প্রতীক সেট
यस सर।
ওকে প্রতীক্ষা ঘোষ
Yes, sir.
ওকে আচ্ছা প্রত্যয় রয় প্রত্যয় নেই। আচ্ছা প্রয়াস বাসু প্রয়াস
Yes, sir.
প্রয়াস আছে। আচ্ছা প্রিন্স কুমার শর্মা তো নেই। রোহিশ রে
यस सर।
ওকে ঋষিন হালদার প্রেজেন্ট। আচ্ছা রূপম সরকার আছে। আচ্ছা সঞ্চিতা দত্ত
Yes, sir.
ঠিক আছে। সপ্তর্ষি সেন নেই। সায়ন চক্রবর্তী
प्रेजेंट सर।
আছে। শেফালিকা আছে। সৌমিক কুন্ডু নেই। শুভম চৌধুরী
प्रेजेंट सर। प्रेजेंट सर।
সুমন ঠাকুর আছে। সুমন ঠাকুর নেই। ঠিক আছে সূর্যদীপ রয় সূর্যদীপ নেই। আচ্ছা ত্রিদীপ্ত নেই। আকাশ চ্যাটার্জি আছে। आकाश नहीं है। आनंद मोहन झा आनंद मोहन झा नहीं है। अंगना दास, অঙ্গনা দাস
প্রেজেন্ট স্যার, প্রেজেন্ট
প্রেজেন্ট
অঙ্গনা
আছো?
দাস।
হ্যাঁ, খুব ভালো, ঠিক আছে। অনিকেত মিশ্রা আছে? অনিকেত মিশ্রা,
Yes, sir. Yes,
बहुत
sir.
अच्छा है, बहुत अच्छा है। অরিন্দম সিংহ,
यस सर।
बहुत अच्छा है। অরিত্র ঘোষ,
यस सर।
ঠিক আছে। আচ্ছা, অর্ণব চক্রবর্তী নেই। আর এখানে কে আছে? অরবিন্দ কুমার মিশ্রা, बहुत अच्छा है। आयुष मिलन,
प्रेजेंट सर। आयुष।
ठीक, आयुष मिलन प्रेजेंट, वेरी गुड। बिलाल अहमद, बिलाल अहमद नॉट प्रेजेंट। दर्शन प्रेजेंट, दर्शन इज प्रेजेंट। अच्छा, गार्गी देवनाथ, गार्गी देवनाथ
Present, sir.
प्रेजेंट, ठीक আছে। জিৎ সাহা
प्रेजेंट सर।
প্রেজেন্ট, ঠিক আছে। কৌশল পণ্ডিত নেই, কিংসুক নেই। আচ্ছা, মেঘা আছে? মেঘা পল,
Present, sir.
ঠিক আছে। মোহিত সাহাল নেই। पंकज घोष, पंकज
यस सर, पंकज।
बहुत अच्छा है। प्रभात कुमार, प्रभात
प्रेजेंट सर।
प्रेजेंट प्रेजेंट प्रेजेंट, ठीक है ठीक है ठीक है ठीक है। राकेश रोशन, राकेश रोशन, अच्छा। रेशमी बार
Yes, sir. Present.
प्रेजेंट। रोहित, रोहित तो আছে। रौनक प्रामाणिक, रोहित प्रामाणिक, रौनक प्रामाणिक नहीं। अच्छा, संजना रानी,
Sir.
आप प्रेजेंट है? प्रेजेंट है,
Yes, sir. Present.
ठीक है
Yes,
ठीक है
sir.
ठीक है, ओके ओके। अच्छा, सप्तर्षि कुंडू है? नहीं है, हमको लगता है सप्तर्षि कुंडू नहीं है। सप्तर्षि रॉय है? क्या है? सप्तर्षि कुंडू, सप्तर्षि रॉय नहीं है, ठीक है। सायन बाग
प्रेजेंट सर।
খুব ভালো আছে, চলো ঠিক আছে। সায়নী ঘোষ
Present, sir.
প্রেজেন্ট, ওকে। সায়ন্তন ঘোষ, সায়ন্তন ঘোষ,
Sir, excuse me.
यस।
Sir, in the previous session, I was present, but due to network issues, I can't give my attendance. Can you please help, sir?
ओके, वेट, व्हाट्स योर नेम?
Sir, Shani Ghosh.
सायनी घोष, सायनी घोष तो প্রিভিয়াস ক্লাস, ওকে না? ইয়া, ইউ আর নট।
হ্যাঁ স্যার, আমি ছিলাম, কিন্তু যখন অ্যাটেন্ডেন্স নিচ্ছিলাম তখন আমার নেটওয়ার্ক প্রবলেমের জন্য হঠাৎ কেটে গেছিল।
আচ্ছা, ঠিক আছে ঠিক আছে, আমি প্রেজেন্ট করে দিয়েছি। হ্যাঁ, प्रेजेंट कर दिए, नो प्रॉब्लम। नेक्स्ट, श्रेय कुमार बर्नवाल, श्रेय कुमार बर्नवाल प्रेजेंट है? एब्सेंट ना प्रेजेंट? हमारे एब्सेंट कर दिए। सिमरन कुमारी, सिमरन कुमारी
প্রেজেন্ট স্যার। প্রেজেন্ট।
प्रेजेंट, ठीक है। अच्छा, स्नेहा गोस्वामी
প্রেজেন্ট স্যার। ইয়েস স্যার, প্রেজেন্ট।
ঠিক আছে। সোহম ভট্টাচার্য তো নেই। সৌতি সামন্ত আছে?
প্রেজেন্ট স্যার, সৌদি সামন্ত।
ঠিক আছে। সৌরভ বাগ, সৌরভ বাগ তো নেই। अच्छा, शुभाशीष पॉल, শুভাশিস পল প্রেজেন্ট আছে, ঠিক আছে। আচ্ছা, এখানে শুভজিৎ দে তো নেই। সুমিত কুমার, সুমিত কুমার। सूरज माइती,
यस सर, सूरज माइती प्रेजेंट।
ओके। वर्धन शाश्वत, वर्धन शाश्वत तो नहीं। रिद्धिमान घोष, हाँ प्रेजेंट। ओ चलो, अटेंडेंस हो गया।
हेलो सर, निखिल कुमार।
निखिल कुमार, निखिल कुमार, निखिल कुमार, आप तो प्रेजेंट बोले तो प्रेजेंट बोले तो आप प्रेजेंट है दोनों बार।
हम तो नहीं बोले सर, आप कैसे दे दिए?
तो हम प्रेजेंट कैसे किए आपको?
पता नहीं सर, हम बोले नहीं है, लेकिन
आप तो चारों दिन प्रेजेंट है, ऐसा कैसे हो सकता है?
अभी नहीं लिए सर, 3 दिन तो प्रेजेंट थे ही।
ये कैसे हो सकता है? निखिल का नाम हम कैसे भूल सकते हैं? आप इतना इंपॉर्टेंट है हमारे लिए।
सर आप मेरा नाम अभी नहीं लिए हैं, तभी तो हम बोले।
सर
अच्छा चलो ठीक है।
sir
क्या আছে? হ্যাঁ সায়ন বাগ বলো, সায়ন বলো।
sir I was present yesterday first class but I can't give my attendance.
আর yesterday তো তুমি অ্যাবসেন্ট আছো সায়ন বাগ, দুটোতেই।
yes sir first class এ আমি attend ছিলাম but মানে দিতে পারিনি attendance টা।
আচ্ছা ঠিক আছে, ঠিক আছে, নো প্রবলেম, চলো হয়ে গেছে, চলো ओके चलो ठीक আছে। सो हमारा 2 क्लासेस एकदम सक्सेसफुल आज कंप्लीट हुआ है। समझने में कोई दिक्कत नहीं हो रहा है ना? किसी को कोई प्रॉब्लम नहीं है तो समझने में?
नो सर।
ओके इट्स वेरी या ओके। अभी और बहुत कुछ बाकी है, ठीक है, अभी बहुत कुछ है, लॉट्स ऑफ थिंग्स आर देयर। मंडे मींस देखिए बहुत इंटरेस्टिंग होगा मंडे, बहुत इंटरेस्टिंग, वेरी वेरी इंटरेस्टिंग होगा मंडे। We will go through each of the yes Arvind, whatever I am teaching, okay, you have to go through it. आपको सब पढ़ना पड़ेगा, मैं जो भी बता रहा हूँ सब कुछ पढ़ना पड़ेगा, ईच एंड एवरी मॉडल, ठीक है। बहुत कुछ बाकी है, अभी अभी बहुत कुछ बाकी है।
Hello, sir.
या
Sir, still now we haven't got the recording
या रिकॉर्डिंग
videos of classes.
I had a talk, okay, I had a talk. You will get each and everything. Right now I'm instructed to give you the study materials, okay, so that you can go through the study materials, you can increase your what to say expertise basically, you know, okay, you will increase your expertise.
Yes, sir.
Right now for 2 class, see, I've shared you the data set, I've shared you the codings, I have shared you the study materials, and much more study materials I will share it to you, okay. So it was instructed to give some study materials so that you gain your expertise, okay. After that recording is there, don't worry, recording afterward you will get, okay, and you will, that recording actually remains for months, don't worry, it actually remains for months, okay. Reshmi, I will give gift, don't worry, okay, don't worry, yeah, it will be helpful, I can understand.
স্যার আজকে সেকেন্ড হাফের রেকর্ডিংটা আজকে দিলে একটু ভালো হয়
আচ্ছা
যদি
ঠিক
পাই।
আছে, ঠিক আছে, আমি কথা বলে নিচ্ছি। না রূপম, ওকে ওকে, ডোন্ট ওয়ারি রেশমি, রূপম কালকে তো রবিবার না, সানডে না, নো টুমরো নো ক্লাস, নেক্সট ক্লাস ইজ অন মানডে, হ্যাঁ মানডে। Okay, yeah, you can leave right now. I will not do anything today because it's already 10 minutes is left, okay, that is enough, okay. Chalo enough for today.
Thank you, sir.
Welcome, take care of yourself everybody, okay, stay safe, chalo ठीक है। এই দীপরঞ্জন এখন বাই নয়, আমি ক্লাস আছে, এখন আছে অনেক, মানডে টিউসডে ওয়েডনেসডে থার্সডে অবধি, ঠিক আছে ঠিক আছে, क्लास है, ओके चलो चलो ठीक है
sir okay sir
हाँ या थैंक यू रिद्धिमान, थैंक यू, वेलकम।
Hello, sir. Hello, sir.
Hello. 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 Shreya Kumar. हेलो श्रेय कुमार, आप कहाँ थे?
Sir, by chance I am network problem. I am got disconnected.
ऐसा कैसे हो सकता है?
Yes, sir. I am
Okay.
trying to join. I am trying to join, but I did not join. My Wi-Fi was network problem, so I am joining through my phone's internet. Can you
Okay.
mark
Okay.
my attendance as present?
Okay. 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 You can leave. No problem. I'll get it. I'll go.
Thank you, sir.